Alright, a couple mallows on the issue here. Um, I just kind of finished up. I'm not 100% convinced on that. I might actually take a picture of the rest of the paper too. I got a couple other notes on there because there's a couple geometries with it just right off the hop. I chose the right hand rule. You'll see that there's some similarities here. I needed four differentials because it's got to be that Dirac space. So you need four here. The four quantization of what it does. I also needed three states that are different. This is positive x. This is negative, positive negative x. This is negative y or negative z or whatever it is down there, and this is positive negative. It's coming from the past, moving with momentum towards the future. And again, I'm a little relative on if it should be that way because 0 or 1 depending on what you're doing. I'm okay with that. The symmetry's good. I'm gonna say a word now, and you're not gonna believe me. It doesn't matter. Yeah, no, it matters. It matters a lot, especially with them spinners in those other states. But as long as we're staying with this symmetry, if I'm 180 wrong there, that's fine. And I think that should carry along with what you're doing. Now, you'll see that this is an interesting state. Let's look at the pattern and how I created it. We're moving this way, and we're also moving this way. I'm individually moving one piece, and why not continue it all the way to the third? Because I don't need to. I already have an inverse of it by the fact that there's this. That's just an XY game that you program that spinner to teleport through what it's doing. So it doesn't necessarily need the logic, but you need to understand the logic. Okay, when we get to the second level of that, here, same condition, but now it's moving. The only one that can't do that is the last position, because there's no real reason. It's got one on this outer barrier, because this is not connected. This is not, I need some way for it to heat decay or something, and down and right is the way I chose to do it. You could do that, and that's its own, it'll reflect and refract. So I think you're good here as long as you keep your negatives right. So that'll give me the four states that I need, where all of them share that characteristic. Now, the thing about the combinations of this, I would imagine, to spinners, is there's more of them. Not only is this configuration technically 1, 2, 3 correct, 1, 2, 3, but it's not. There's going to be a multiple configuration plus a random cryptology to it in this topology. So you're going to get to the single topologies or the multiple, the singlet topologies. I forget what he was talking about in the spinners there for the types of homogenized topologies you're dealing with. Because the brain can't handle that fourth dimensional object, like a fourth or fifth dimensional object potentially here, that you can't really describe the shape of it like that. So you need to come up with something like this, I would imagine, to why you want to use it for the cover of your book or something like that. Here I'm having an M1 or an M0 state. You could probably apply it to the classical, what is it, SO2 or SU2 aspects of it, because it's kind of there. It's an S1 and S2 area where you only need one or two of those topologies. I don't actually need three topologies. I'm only doing one thing. It's going to move. There's going to be a state of it where it's all connected, but because I wanted to stay with this state of triple, to the XYZ or to the XY with 1, 5, there is a point where that spinner gets to acting a little bit weird. And I believe it's because of something like this, that all of it sums down to infinity, but because of the range we use math in, it's not real practical. We don't need to do that. You don't need to memorize Dirac's equation like that. Oh, and I just remembered the space on this too, but essentially I'll look at it as like a wave function. I'm starting high in the negative, in the past, and I'm moving towards the future in this positive for 1 on the bar graph. And if you look at that wave function, that's why these constants or these equations aren't going anywhere. When it comes to that equals mc squared, or excuse me, mc, which is mass causal, but the speed of light. Because here, speed of light is relative to the medium I'm in spinners in the Dirac's equation. This is what defines light, not necessarily what it is. Yes, that'll be hydrogen, but as long as we're not utilizing that scale of the symmetry, it's fine, right? You know that it's emitting sunshine. There's some kind of way it decays. It's in this position where it wants to be to a full state or drop to its singularity, which I have in an order here of not its full state to its full state, where it repeats that pattern again, here inverted, because this is that other part of the shell where I'm basically saying in order to complete all this, it's got to run that cycle. When that runs that cycle, then this part is not filled in, because binary, it's got to change fields. Can't have positive. It might be in there as an operator. What is it? Wave function x1 x a x b. I want to say x0, but I'm not real sure about that. And then that multiplies like a matrix in itself. Negative wave function x1 x1. A couple of them that do that. They're topologies that you can use to. They are spinor designs. I'm not gonna ever graph negative time. Like I can only agree that time is in this space. It might be coming in at an angle. It might be moving up off of a cycle, but it really can't be anything but those topologies. When we're doing this way with the spinors or with Fourier or something like that, I need to know those states. I'm applying that. I'm in a certain momentum or kinetic of the, and I know that's not right there, but of the event. So I have to be able to separate what units by the proper mass. If you get to the electron or to the proton or the nucleus, they have different gold slit experiment characteristics. There's no way that the physical math to that scale, which I believe is if you do it here, a circle, it's something to do with like on this half or on this half, but you get this type of problem with it. And then there's an open in space equally like it's here in the middle. So that gives me what? Open, 1, and because there's that symmetry to it, potentially 2, but are we just going to reflect it, or are they XY different enough to determine as a category before I put that in the center? So 1, 2, center, and then far on this outside, but do you need it? This could have continued another set and I would have had that 4x4, but that's not what I was looking for to try to deal with Dirac's equation with a physical geometry. I need something that was going to terminate to a set. So I might have needed to manipulate the rules of that spinor, right? There he's just rotating at random or potentially off of hydrogen, but there's a lot of other aspects of what it could be used for. The idea here is not only in neutron stars, but understanding the quantization of it, and Dirac's spinor quantization is apparently you can make what should have been with the charge super hot metal, like it would have been electricitatively hot, but because they got it to act bosonically, apparently it's cold. Well, if you get the configurations just right, well, yeah, stoichiometric ratio, no oxygen, no fire at all. Proper oxygen, or even too much oxygen. Well, would too much oxygen would act to the accelerant, so probably not be. It would burn up very fast, like a cigarette with oxygen through it. You get that state just right, and then those temperature conditions, and you might get that nanosecond of a window for you to properly, kerosene distillation. There's a lot going on. If you FMA a choice without properly orientating what the spin direction is on that stuff, either in its elementary components, but also in amounts and proportions that they are there, then you're going to probably more than likely be all over the road when it comes to the snowflake, if that helps.